Thank you very much, Lance. So today I would like to talk about actioning knowledge graph. And in order to explain what I mean by that, I would like to travel back in time to one of the most popular, probably the most analyzed knowledge graph in history. And I'm talking about the Panama Papers. And you probably remember a few years ago when the journalists of the ICIJ got hold of this massive data leak from the company Mossack Fonseca. They were facing this kind of needle in a haystack problem, where they were wondering how to make sense of such a ridiculously big amount of data. And you can see how it compared to other popular leaks like the WikiLeaks, which is tiny compared to the Panama Papers. But they had this brilliant moment, this game-changing moment, where they decided to focus on the connections in the data. They thought, let's try to identify the individuals, the entities, the organizations that are mentioned in these raw data. Let's try to extract the relationships that connect them, because they believed that exploring these connections, they would uncover relevant and important stories. And that's, well, we know the rest of it, right? So all the stories that were uncovered and published in the news over the years. But the angle I want to focus on is in the work that the technical guys, the data team of the ICIJ did. And we mentioned how they built these data pipelines that extracted the data, the entities from the raw data in the leak, and built this graph in Neo4j. But the story didn't end there, because following the Panama Papers was Paradise Papers, the offshore leaks, and so on and so forth. And surprise, surprise, in these new leaks, some of the individuals that were mentioned in the Panama Papers were there again. So effectively what they were doing, they were constantly enriching this knowledge graph with new leaks, with the results of additional investigations. And their job was to make sure that every morning the journalists had at the tip of the fingers fresh release of the knowledge graph for their investigations. And that, if you think of it, it's not very different from the problems you are facing on a daily basis as a CIO, as a data owner. Your job is to make sure that the right data is in the hands of the right people. And that may sound a straightforward statement, but that involves having a good understanding of your data state, of your data ecosystem. And you know that being able to trace the data journey, if you want to call it like that, from the point where it's produced to the point where it's consumed, whether that's in a dashboard, in a report, is extremely important. And that will not only give you visibility, but will also let you give you the ability to invoke action. And here's the first mention of action. So as Maya introduced in her presentation, a graph becomes a knowledge graph when we overlay an organizing principle, when we apply some semantics that make your data smarter, and you can make it possible for you to run more sophisticated exploitation of that data. So that's something that knowledge graphs do in a natural way. And let me take an example of this idea of making your data smarter. We have a simple statement there. We have a customer, a user subscribing to a particular service, and that will make it possible for us to answer questions like, what services that this particular user subscribed to. But if we overlay information, for example, on data provenance, on data ownership, on data stewardship, we will not only be able to answer the question, but provide trust, provide additional information on we can answer the question in this way, because the data comes from this source, it's curated by this person, and then we add additional value. And that's something that a number of organizations have realized, the value of representing these data pipelines, the way data moves across your systems, and that's traditionally called data lineage. That's something I was mentioning, that a number of organizations have realized that it's actually a graph problem. And it all started, that's kind of a rough timeline, but it started in 2017 when the data portal team at Airbnb built a platform to be able to precisely track the usage of data, but not only putting the focus on data lineage, but also bringing in additional information on who were the consumers, who were the producers of data, what was the frequency of update of certain data sources. Something similar is what the team at Lyft at the time did with the Amundsen platform. Amundsen now has a life of its own, independent, as an open source project. And similarly with the team, the Data Hub team at LinkedIn. So this idea of building a metadata hub based on a graph is incredibly valuable, as you can see. And you're going to hear from Manta only a few minutes after I finish how they're using also graph for data lineage. Because, like I was mentioning before, you will not only be able to understand where data is produced, how it's consumed, the journey that it goes through, but you will be able to action on that data. For example, understanding who are the consumers of a particular data set. You will be able to notify them of any incident on a particular pipeline. The pipeline broke overnight because there was a data quality issue. I know who I need to notify. I know which processes, which consumers have been affected by that. So that's the value of a knowledge graph for metadata management, actioning knowledge graph in metadata management. But probably just to give a little bit of additional insight, I thought I'd show what a possible data pipeline or this type of knowledge graph can look like. And there we have at the center of the graph a transformation, and that can be an ETL process of any kind that in this case is broken down into steps, some kind of standardization followed by some kind of aggregation. But it points to the input, which is a data set that comes from a CRM platform, and the output is another data set, a transformed data set that will be hosted in some kind of cloud storage. And these data sets have owners, have people that are responsible for them, and they can also be organized in teams. It's interesting, this idea, because one important angle for this type of data hub solutions is this element of a social network as well. Let's think of this a situation where you have a new data scientist in your organization that wants to run some, build a predictive model on churn prediction model on your customer behavior. Well, you want to make sure that they have access to the freshest data. Which is the right data set? Should I take the one coming from the CRM? Should I take the one coming from this operational data store? Well, all these will be hosted in this metadata hub, not only with information on provenance, but also with information on who's consuming these data sets. And you can look at things like the members of my team are consuming these data sets. Maybe I would be interested in them as well. So we can apply this kind of social and network techniques. And that's something that this discoverability recommendation that projects like I mentioned before, Amundsen used and implemented. And an important outcome of this is also the fact, and this is a quote from the data portal team at Airbnb, is that this representation, representation of your data ecosystem in the form of a graph is a proxy of the operations of your organization, and will also help you not only react, like we mentioned before, an action to certain events, but it will also provide you insight on the operations of your organization and help you, for example, detect broken communication channels between departments, situations where silos are being created, teams are being knowledge is being kept separate in silos. So this kind of thing is an important and additional benefit of this approach. Now, on a completely different use of actioning knowledge graph, and let's remember, I'll repeat it several times, a graph becomes a knowledge graph when we overlay an organizing principle, some kind of semantic, some kind of information how the data is supposed to be interpreted in a way that it can be actioned. So in a completely different use case, as I was mentioning, it can be used for personalization and recommendation. And I thought I'd put a simple example here, for example, of a purchases by customers. Right? We see information nodes representing customers and the electronics that they've bought. And you see that, for example, that some of them have bought the Apple AirPods and all the different models. And these products are tagged with categories, like this is a product, this is an earphone, this is a wide one type, it's an audio piece of equipment. But this information is not structured, and some additional structure would help me running some more sophisticated use of this data. And that's exactly what we do when we overlay in this case, a taxonomy. Taxonomy is one possible organizing principle that I can overlay on top of my data catalog. In this case, could be an ontology, but by doing that in this case, now I can say, well, because you're interested in Apple EarPods and they're part of the same category as these other Shure earphones, maybe this is a product that's potentially relevant for you. So this idea of jumping seamlessly from the data and metadata plane from the data and the organizing principle is extremely valuable. And that's the principle that's at the core of the actioning knowledge graph. Now, I thought I'd use a couple of minutes in this presentation to talk about RDF. And the reason is because we very often come across it as a kind of a question. I mean, does a knowledge graph need to be implemented using RDF principles? Sometimes it's used as a way of prescribing a particular technology stack. And I thought, that's wrong. That's a misconception. And I wanted to just spend 2 minutes explaining what RDF is. And I'm going to use a very simple example. So this is the world. This is a situation where there's an individual, that's me, Jesús Barrasa, working for a company which is Neo4j. I can describe that using RDF. And the RDF is a kind of a very low-level model that's built on the notion of a triple, of a statement. Right? Where we have an individual, that's me, that has a type, which is a person, it has a name, JB, it has a date of birth, an academic degree. They have the same kind of information for an organization. It's a company. The name is Neo4j. It was established in 2007, and so on and so forth. And we can even have statements that connect the two together. So this individual 1, 2, 3, 4, which is JB, works for Neo4j, works for this organization. So yes, effectively that builds a graph, but it's kind of a very low-level one, and that's normal because RDF was defined as a model for data exchange. That's the kind of information that an API will export, and that a data consumer will consume. But it's probably not the one that we want to use to manage our data, to ask questions of our data. That requires a more humane, a higher level model like the property graph. And exactly the same information would look something like this. We have a notion of a node, a person, not necessarily a sequence of statements, which is fine when data is distributed. That's at the origin of RDF, the notion of the semantic web. But we like to talk about things, a person that works for a company, nodes and relationships, the principles of the property graph. Because by having a model like this one, I'll be able to ask questions like, which company does JB work for? And I'm kind of drawing these kind of high-level entities, these kind of high-level model entities, like you see the matching in the colors. So that's the idea. RDF does not impose any restriction on how the data is stored, what's the stack. You can be perfectly compliant with RDF using a property graph like Neo4j, but that will be typically your model for data exchange. So I thought I touched on that very briefly, and similarly on the notion of ontologies. Again, that can be kind of a dividing factor sometimes, but I thought I'd mention this example that we run in another webinar a few months ago, where we used public ontologies, because an ontology, like I was mentioning before, is a description of the domain that can be overlaid on top of my data. And that's exactly what we did in this example. So we took some technology articles, we picked a public ontology from the web, serializes OWL, and that's seamlessly imported into Neo4j. And then we could use this overlaid ontology to drive recommendations, something similar to what I just showed on the product catalog, but that was used on topics on a knowledge base of articles, I could say, because you were interested in this article about Neo4j, you might be interested in this other one about Cassandra, because both share the notion, both are subcategories of NoSQL databases. Well, that was another example of an actioning knowledge graph. Again, we can implement, we can take action on this explicit knowledge that we built into the graph. Right, so that's me. I'm going to conclude with some call to action, where to go next. Well, I think that the important thing of the actioning knowledge graph is precisely that, the action. So identify what's the purpose of your knowledge graph. Why? What's the reason? What's the kind of action that you want to implement on your data, and why do you want to make your data smarter? Because then that will drive how you will build the right semantic overlay for your data. And of course, build that incrementally and make sure that after every iteration, there's value being added. some resources there for your consumption. I'll stop here. Thank you very much.
Thank you so much, Jesus. It's always such a pleasure having you here. I want to remind the audience that Jesus will be joining us again later today for the expert panel discussion. Stay tuned. The next session will be starting in just a few minutes. Thanks so much.
Thank you.